Good morning, students. Today we'll continue the second chapter of physics, that is magnetic effect of current. Firstly, we deal with the magnetic field due to current in a circular loop. Before discussing this thing, we must know about the magnetic field due to current in a straight conductor. Let us consider this is a straight conductor and some iron filings are kept on this cardboard, and this wire is connected to a battery. So when electric current is passed through this wire, then this wire is converted into a magnet. Now when we tap the cardboard, we'll see the iron particles arrange themselves in the form of concentric circles. Iron particles arrange themselves in the form of concentric circles, showing the magnetic field of the magnet. Now, the direction of magnetic field can be determined by right hand thumb rule or right hand grip rule. And this rule, right hand thumb rule, states that if a current carrying wire is held in our right hand in such a way that thumb indicates the direction of current, then the fingers encircling the wire give the direction of the magnetic field or magnetic lines of force. You see in this diagram, current is moving in the downward direction. So we have to place our thumb in the downward direction. Then curling of other fingers should be in clockwise direction. So you see the direction of the magnetic field or magnetic lines of force is in clockwise direction. So this is the magnetic field pattern of a straight conductor carrying current. We can do the same thing by reversing the direction of current. See the diagram once again. Suppose it is a cardboard and a current carrying wire is kept here. We just reverse the direction of current here. Here current is moving in the upward direction, right? So when current is passed through the wire is changed into magnet, and when we tap the cardboard, we'll see the iron dust or iron filings arrange themselves in the form of the concentric circles, showing the magnetic field of the magnet. Here current is moving in the upward direction. So as per right hand thumb rule or right hand grip rule, thumb indicates in the upward direction, and in this case curling of fingers should be anti-clockwise. So this gives the direction of magnetic field in this particular case. So this is the magnetic field pattern of a straight conductor carrying current. Now we will deal with the magnetic field due to a circular loop carrying current. The same experiment is done, but in this experiment we will choose a circular loop instead of a straight conductor. You see, a circular loop is taken and it is connected to a battery. Now electric current is passed through the loop and it is converted into a magnet. And on the cardboard, some iron fillings are also kept, and when we tap the cardboard, we'll see the iron fillings arrange themselves in the form of concentric circles, showing the magnetic field of the magnet. Now, the direction of the magnetic field can also be found out by using right hand thumb rule or right hand grip rule. Say in the first part of the wire, current is moving in the upward direction, so we have to point our thumb in the upward direction, and curling of fingers should be anti-clockwise, and that gives you the direction of the magnetic field in this part. And the next part, current is moving in the downward direction, so we have to keep our finger downward, thumb downward. And for curling is done in the clockwise direction, and that gives the direction of the magnetic field in this particular wire. So this is the magnetic field pattern of a circular loop carrying current. Now, our next topic, magnetic field due to current in a solenoid. Before discussing about the solenoid, we must know about the clock rule. Clock rule. Now the question is, for which purpose this rule is used? Clock rule is used to find the polarity of the magnet. Polarity of the magnet means which part is indicating north and which part is indicating south. That can be find out by clock rule. Now let us discuss about the clock rule. Suppose we are considering two circular loops, right? In first loop, current is moving anti-clockwise, so we have to draw two curved lines at two sides of the circle. Now you see, we just draw it once again. In this loop, suppose current is in anti-clockwise direction, so we draw two curved lines and put the arrow as per the direction of the current. Now free ends are joined by a dotted line, and we will get the English letter N. So if current is anti-clockwise, then north polarity is developed. So we get the first one when current is in anti-clockwise direction. Now suppose current is clockwise, then what has happened? See in this diagram, current is clockwise. Again we have to draw two curved lines and put the arrow as per the direction, and free ends are joined. We get the English letter S. So if current is clockwise, then south polarity is developed. and this is a clock rule. I just repeat once again, if the current is clockwise, then south polarity is developed, and if the current is anti-clockwise, then north polarity is developed. This is all about the clock rule. Now we deal about the solenoid. What is solenoid? Solenoid is a circular coil of wire in the shape of cylinder. Solenoid is a circular coil of wire in shape of cylinder. You see, circular coil in the shape of cylinder. Obviously, it is connected with the battery, and the system is considered as a solenoid. Now we want to find out the magnetic field due to current in a solenoid. See, suppose it is a solenoid and electric current is passed. So obviously it behaves like a bar magnet. At one end, current is clockwise, and another end, current is anti-clockwise. So you see, when current is clockwise, then obviously south polarity is developed, and when current is anti-clockwise, then north polarity is developed, and this is the magnetic field lines due to current carrying solenoid. So current carrying solenoid behaves like a bar magnet, and its poles can be found out by using clock rule. Now, strength of solenoid can be increased by two ways. One, by increasing number of turns of the coil, by increasing number of turns of the coil, and second, increasing the magnitude of current. So strength of solenoid may be increased by increasing the number of turns of the coil and by increasing the magnitude of current. Let us explain it. Suppose we are taking two solenoid. This is the first one. Here number of turns is 2. Another solenoid is there. You see, here number of turns is 3. And another solenoid is there. Its number of turn is 4. So since in last solenoid number of turn is maximum, so its strength is maximum strength. So strength of solenoid can be increased by increasing the number of turns of the coil. Second one, by increasing the magnitude of current. Suppose number of turns is 2, and through it 2 ampere current is passed. In the second solenoid, here is the number of turns is 2, but through which 3 ampere current is passed. And another solenoid is there. Its number of turn is 2, and through this solenoid 1 ampere current is passed. So in the second solenoid, maximum current is passed, that is of 3 ampere. So it has a maximum strength. So from this experiment we can say that strength of solenoid can be increased by increasing the number of turns of the coil and by increasing the magnitude of current. So today we deal with magnetic field pattern of a straight conductor carrying current magnetic field pattern of a circular coil carrying current, right hand thumb rule, clock rule, solenoid, magnetic field pattern of solenoid, and how the strength of solenoid is increased. Today is this much. In the next class, we will deal after the solenoid. Till then, thank you.